To begin with, the initial step involves writing the Arduino code, which is a crucial part of the process. This code will serve as the foundation for the project, ensuring that all components function correctly and efficiently by I'll make it short like this. If you look now, I've uploaded it, and it's toggling between AB and AB. Then, based on this, when we connect to Android, it will display A if it's A and B if it's B. Next, we covered up to implementing the serial provider in this app last time. So, the children, wrapped in this serial provider, can use the use serial. In simple terms, this means they can utilize the context. The role has evolved into what is now known as the serial manager, a position that involves overseeing the organization and management of serialized. I will register the necessary and appropriate event listener related to the serial manager. In the context of programming, particularly when dealing with serial communication, the serial event callback type is a crucial concept. It is defined as a function or a method that is automatically called in response to a specific event occurring during the serial communication process. This type of callback is essential for handling asynchronous events, ensuring that the program can respond to data being received or other events without blocking the main execution flow. Now, when we say that the serial event callback type is set as a serial event callback, we are essentially confirming that the function designated to handle these events is correctly assigned to manage them. This setup is vital for the smooth operation of serial communication, as it allows the system to efficiently process incoming data or signals. Furthermore, the term scrollback refers to the ability of the system to review or revisit previous data or events that have occurred. This feature is particularly useful in debugging or monitoring scenarios where understanding the sequence of events is crucial. So, when we ask the serial event callback type is set as serial event callback, right? And it's scrollback, isn't it? We are essentially verifying that the configuration is correct and that the system has the capability to review past events, ensuring everything is functioning as intended. If it is set up, and then a serial event occurs, it cannot be executed. In the next phase of our project, we will be closely observing and keeping track of the serial manager, which is a crucial component in our system. This involves actively monitoring and managing various serial events that occur within the system. At this stage, we have implemented a basic type of monitoring, which serves as a foundational step. However, this is just the beginning. As we progress, there is a wide array of possibilities and functionalities that we can explore and implement. These could include more sophisticated event handling mechanisms, advanced data processing techniques, and potentially integrating ASCII, which stands for American Standard Code for Information Interchange, is a widely used character encoding standard in computers and electronic devices. It allows for the representation of text by assigning a unique decimal value to each character. If you look at the ASCII tape now, you can see that we are sending lowercase aa and lowercase b. In this system, A corresponds to the decimal value 97 and B corresponds to the decimal value 98. This encoding is crucial for computers to process and display text efficiently. Now, let's consider the use of a switch in this context. A switch is a device that can open or close an electrical circuit, thus controlling the flow of electricity. In our ASCII transmission, a switch might be used to toggle between different modes or states, affecting how data is transmitted. Should we just toggle it for now to observe its impact on the transmission process? This could provide insights into the practical application of switches in managing data flow and controlling operations within computing systems.
Let's delve into this concept with a bit more detail to ensure clarity and understanding. Imagine a scenario where we have a condition which we will refer to as A. If this condition A is met, then the outcome will also be A. This is a straightforward situation where the condition directly leads to the expected result. However, if the condition A is not met, then we must consider an alternative outcome, which we will call B. In this case, B represents a different path or result that occurs when the initial condition A does not hold true. To put it simply, the presence of A leads to A, and the absence of A leads to B. This logical structure helps us understand the relationship between conditions and outcomes in a clear and concise manner. By examining these possibilities, we can better anticipate and respond to various situations that may arise. This approach allows us to maintain a structured and logical framework for decision making, ensuring that we are prepared for both expected and unexpected scenarios. Now I will just run this. Currently, the Android device is connected to my personal computer, and it is connected via USB. However, this Android phone has only one USB port. Whether it's USB-C or micro B, when using an embedded Android device, there may be multiple ports for debugging and other slave connections. However, if you connect your own Android phone to a PC, we won't be able to connect to the Arduino. Since there are no limits with the USB port, in such cases, debugging cannot be done. When you connect the Android device to the phone, you cannot connect it to the PC, which prevents debugging. In this case, you need to connect the Android Debug Bridge, ADB, wirelessly. As you can see here, I have made the connection, and when I run ADB devices, it shows that it is currently connected via USB. In this state, I will open a port using ADB TCP/IP 555, which opens port 555 on the phone. Just a moment. Let me open the mirroring again. Now, with the port open, if you go into the Wi-Fi settings, the prerequisite for this is that the PC and smartphone you want to connect wirelessly are on the same network. As you can see here, this is 192.168.86.34, the local IP. So I connected using ADB Connect 192.168.86.34. The ADB device's screen shows that it is now connected. If I remove my hand, in this state, the screen will disconnect and the mirroring will also stop. However, if I type ADB devices, in this state, it shows that it is now connected wirelessly. I will reopen the mirroring at 192.168.634. The SCIAR CPI mirroring is now connected wirelessly and seamlessly. In this current state, I will carefully connect the Arduino here. For the initial connection, I will first connect the hub and then proceed to use a USB-A to USB-B cable, connecting the A side to one end and the B side to the other. I have connected it through the port like this. Do you see the TX LED blinking continuously right now? Every second? It's currently sending AB, AB, Arduino. Now, I will run my Android app. In this state, I will launch the Android project, opened from the project folder. Just to be absolutely and completely sure, I will run the Android. It asks if you want to connect the USB device like this. Then, confirm. First, you should press the button labeled B, followed by the button labeled A. Then, repeat this sequence by pressing B again, and finally A. As you can see, the Arduino is sending A and B every second, and each time, the Android screen is receiving the serial communication, so you can see it switching between A and B. Let me check the code one more time. As you can see here, there isn't really much going on, because we wrote all of the essential code on the serial context side last time. Here, we have set it up to bypass all of this data received in our listener and pass it as an event which we have carefully designed. Then again, on our manager side now too, we're listening for these events while checking if it's indeed read data or not. If yes, we retrieve current values corresponding directly towards ASCII codes 97 and 98, meaning A plus B. So, if it's A, I've set it up so that it simply changes between A and B based on the true or false settings. In this session, we connected the Arduino and Android and set it up so that the screen changes based on the data coming from the Android. For now, I've set up a simple automatic connection, but in the next session, I will explain how to connect manually. Then, I'll see you next time.